All right, moving on to question 9 on the math subject GRE practice test. This question we're dealing with probability. Fun. We're told that we have 10 light bulbs in a box, okay, and 3 of them are defective. What we're going to do is choose 2 light bulbs from this box at random. We're not going to replace them, and we're supposed to figure out what's the probability that at least one of the 2 will be defective. Big red flag here. When you see this phrase, at least, really what this is asking you is for the probability that one is defective or both of them are defective. This problem is really asking you to do 2 things. Calculate these 2 probabilities and add them up. Nobody wants to do that. That's a lot of work. Often when you see the word at least, you can be kind of clever. And instead of figuring out the probability that's asked, figure out the complement of the probability that's asked. So what would it mean to not have at least one of the 2 light bulbs be defective? Well, that would mean that none of the light bulbs are defective. I could do 1 minus the probability of the complement and get my answer much more directly. So let's see, probability that none are defective. In order for none to be defective, the first one that I draw has to not be defective. Remember, we start out with 10 in the box and 3 are defective, therefore 7 are not defective. So since I'm drawing these at random, there's a 7 in 10 chance that the first one that I draw is not defective. Now that I've taken out one of these light bulbs that's not defective, I have 9 left. All 3 of the defective ones are still left, so there's 6 that are not defective. So when I draw my second light bulb, the probability that it will be not defective is 6 out of 9. The probability of both of these things happening is the product of these 2 probabilities. You could multiply straight across. These numbers will get a little bit big though. Maybe I could change this one into 2/3, and then I can cancel out this 2 with the 2 from down here. That would give me 7 times 1 up top and 5 times 3, or 15 down on the bottom. You're like, oh, cool, 715, that's my answer. I see it right here, part B. No, be careful. What we just figured out is the probability of the complement. We figured out the probability that none of them are defective. If we want the probability that at least one is defective, we need to consider all of the cases and subtract the ones that don't work. I guess I should be a little bit careful about how I'm writing this. This 7/15 is the probability that none are defective. What we want is 1 minus 7/15. In other words, 15/15 minus 7/15. In other words, 8/15. The answer to this question is C. This complement trick can save you a lot of time. In case you don't believe me, or in case you want a little bit more practice with probabilities, I'm going to solve the problem this way. To figure out the probability this way, as I mentioned before, there's 2 different questions. I need the probability that one of the light bulbs is defective, and then I need to add to that the probability that 2 of the light bulbs are defective. For one of the light bulbs being defective, there's really 2 cases, right? I could get defective, then non-defective, or I could get non-defective and then draw a defective one. Turns out these probabilities are the exact same, but in case you don't see that, the probability of the first one we draw being defective is 3/10 because we have 3 defective amongst the 10 light bulbs. If we drew a defective one, we'd only have 2 defective ones left among the 9 remaining light bulbs. So for the probability of the second light bulb being non-defective, there's 7 non-defective ones left amongst the 9 that are left. This product is the probability that we draw a defective light bulb, then a non-defective light bulb. Again, you can multiply straight across, or you could cancel first. I'm going to cancel to keep the number smaller. This 3 and this 9 leaves me with the 7 up top and a 30 down on the bottom. The probability of first drawing a non-defective light bulb, remember we start out with 3 defective amongst the 10, so there's a 7 in 10 chance that we'll draw a non-defective light bulb. If we remove a non-defective light bulb, there's still 3 defective light bulbs left amongst the 9 that are in there. 7/10 times 3/9 ends up being the same as 3/10 times 7/9, because multiplication is commutative. Reduce this fraction to 1/3, and you'll get 7/30. Add up these 2 probabilities, you get 14/30, in other words, 7/15. That's the probability of drawing exactly 1 defective light bulb. But that's not what we're looking for. We don't want exactly 1, we want at least 1. So we need to add to that the probability that we draw 2 defective light bulbs. Well, we've probably done enough of these cases that that'll be pretty straightforward to you. There's 3 defective light bulbs. Out of the 10 in the box initially, we've gotten rid of one of the defective light bulbs, so there's only 2 remaining out of the 9 left in the box. Multiply and cancel. Let's see, we can cancel a 3 and we can cancel a 2. We get 1 out of 15. The probability of drawing 2 defective light bulbs is 1/15. 7/15 plus 1/15 gives us the overall probability of drawing at least 1 defective light bulb. That's 8/15, the same answer we got over here, considering the complement case, which was a lot more straightforward. and maybe more importantly, a lot quicker for the purposes of a timed test.